Hello students, welcome to the channel. On the ACT math section, you see probability questions that are slightly more advanced than the probability questions tested on SAT math. So in this video, we would look at such questions. If you're taking the SAT, you can skip this video. So let's get started. Let's quickly go through what probability means. The probability of an event is defined as the ratio of the number of favorable outcomes to the number of total outcomes for any event, right? What do we mean by that? So let's say we have to find the probability of getting a 3 on the roll of a die. Now, when you roll a die, how many total outcomes can you get? You can get a 1, a 2, a 3, a 4, a 5, or a 6, right? So you have a total of 6 outcomes when you roll a die. And getting a 3 is one of those outcomes, right? So the number of favorable outcomes is 1 divided by 6, the number of total outcomes. So this is 1 by 6. Okay, what is the probability of not getting a 3? Not getting a 3 would mean any of the other 5 events can happen, any of the other 5 outcomes. So this would be 5 by 6. You can also come to this answer by doing 1 minus 1 by 6, because the total probability of getting a 3 and not getting a 3, that should sum up to 1. So if you have the probability of getting a 3 as 1 by 6, the probability of not getting a 3 would be 1 minus 1 by 6, which is 5 by 6. Now, in a deck of 52 cards, what is the probability of choosing a red card? So a deck of 52 cards is made up of 13 cards of clubs, 13 of spades, 13 of hearts, and 13 of diamonds. So these two are the black cards, and these two are the red cards. So what is the total number of outcomes? We have 52, of which the red cards are 26. So the probability of choosing a red card is 1 over 2. What is the probability of getting a sum greater than 8 on the simultaneous roll of 2 dice? So let's look at this one. So we have sum greater than 8. So first, let us find the total number of outcomes, right? So we could get a 1 and 1, we could get a 1 and 2, a 1 and 3, a 1 and 4, a 1 and 5, and 1 and 6. And then similarly, 2 and 1, 2 and 2, and this goes on. So the total number of outcomes would be 6 multiplied by 6, which is 36, because there are 6 possibilities on the first die and 6 on the second die. Now you're looking at a sum greater than 8. Let's see. If I get 3 and a 5, that's 8, but I want greater than 8. So if I get a 3 and a 6, or a 6 and a 3, that satisfies. If I get a 4 and a 5, or a 5 and a 4, that satisfies. 4 and a 6 and a 6 and a 4, that satisfies. If I get a 5 and a 4, which I've already included, that satisfies. And if I get a 5 and a 6, or a 6 and a 5, that satisfies. And that's it, right? So we notice that with 3, 6, 6, 3, 4, 5, 5, 4, 4, 6, 6, 4, and 5, 6, and 6, 5, we get a sum which is greater than 8. So we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 outcomes which give us a sum greater than 8. So the required probability would be 8 over 36, which is 2 over 9, right? So this is how you have to solve questions. You have to first get the total sample space, the total number of outcomes, and then you have to get the number of favorable outcomes. Okay, let's look at the next one. When two coins are flipped, what is the probability of getting both heads? Let me just clear this. So again, how do I get the sample space? Two coins flipped, I could get a heads and a heads, I could get a heads and a tail, I could get a tail and a heads, or I could get a tail and a tail. So the total outcomes are 4, of which both heads is one of the outcomes. So the answer is 1/4. So this is the basic idea of a probability. Any question, we try and find the total outcomes and the favorable outcome. Okay, let us now look at independent events. For example, one day will be randomly selected from the 7 days in a week, and 1 month will be randomly selected from the 12 months in a year. What is the probability that the selected day will be a Tuesday and the selected month will be a January? So selecting a day from 7 days, a Tuesday from 7 days, and selecting a month, January from 12 months, these are independent events because one does not affect the other, right? So when I want to find the probability of selecting a Tuesday and the probability of selecting January, in independent events, it would simply be the probability of selecting a Tuesday multiplied by the probability of selecting January. So one Tuesday out of 7 days is 1/7. And 1 month, January out of 12 months is 1/12. So that becomes 1/84. Option F. Okay, let's do some questions now. A package of candy contains pieces, each of which is one of 6 possible colors: brown, red, green, yellow, orange, and blue. In each package, 1/3 of the pieces are brown and the remaining pieces have an even distribution of the other 5 colors. What is the probability that a piece drawn randomly from the package is red? So you can see that there are 6 colors, right? Of which 1/3 are brown. So 2/3 are the other colors. Each of the other 5 colors correspond together and make 2/3. And so one color out of these 5 colors will be 2/3 divided by 5, because these 5 colors are red, green, yellow, orange, and blue. So just one color, red, would be 2/3 divided by 5, which is 2/15. Okay, let's move on. A bag contains 16 red marbles, 7 yellow marbles, and 19 green marbles. How many additional red marbles must be added to the 42 marbles already in the bag so that the probability of randomly drawing a red marble is 3/5? So there are 42 marbles in the bag, right? And there are 16 red, 7 yellow, and 19 green. Okay. Now let's say I add X red marbles to the bag. Then what is the probability of drawing a red marble? There were already 16 red marbles and I added X. So red becomes 16 plus X. What about the total? The total, there was already 42 and I added X. So total becomes 42 plus X. So 16 plus X divided by 42 plus X, this should be 3/5. So 80 plus 5X is 126 plus 3X. So 2X is 46, so X is 23. So you need to add 23 marbles to the red bag to get this desired probability. Okay. The Harrisburg Recreation Center recently changed its hours to open 1 hour later and close 3 hours later than it had previously. Residents of Harrisburg aged 16 or older were given a survey and 560 residents replied. The survey asked each resident his or her student status, high school, college, or non-student, and what he or she thought about the change in hours, approve, disapprove, or no opinion. The results are summarized below. Suppose a person is chosen at random from these 560 residents. Which of the following values is closest to the probability that the person chosen will not be a high school student and will not have replied with no opinion? Okay, so we have to find not high school student and not no opinion, right? So high school student not intersection with no opinion not. So by set theory, this becomes high school union, no opinion, whole not considered, whole not, right? So how many high schoolers? 30 plus 4 plus 11. How many no opinion? So the total is 30 plus 4 plus 11 plus 6 plus 47. And we have to take the reverse of it, the complement of it. So this is 34, 45, 51, 51, 98. So 98 is the union of high school and no opinion. So what is the complement for this? It would be 560 minus 98, which is 462. So there are 462 people who belong to this group, not high school and not no opinion, right? So that's my favorable outcome. So my probability is 462 over 560. So let's plug that in. 462 divided by 560, that comes to 0.825. So the answer is 0.83, right? So set theory can be useful in probability questions. Okay. The table indicates the grade 10 or 11 and high school, north or south, of the 270 districts, 270 students enrolled in Algebra 2 in the Green City House district. Suppose two of these students will be chosen at random to represent the Algebra 2 classes at a local STEMS event. Which of the following expression gives the probability that both chosen students will be from the same grade and the same high school? Both from the same grade and the same high school. So if it's grade 10, then north, or grade 10 south, or grade 11 north, or grade 11 south. So if they are both from grade 10 north, then the first student being from grade 10 north would be 47 by 270 because the total is 270. And the second student also being from this would be 46 by 269, right? Because we have already selected one student. So this is the case for grade 10 north. Now, or would indicate a plus. For grade 10 south, the first student being grade 10 south is 93 by 270. And the second would be 92 by 269. Plus for grade 11 north, 73 by 270 into 72 by 269. And plus 57 by 270 into 56 by 269. So from the options, the right answer becomes option A. So I wouldn't call it complicated, but yes, if you're comfortable with set theory and combinations, then probability questions on the ACT can be solved. So hope this exercise was useful. If it was, hit like and subscribe to the channel. Let me know in the comment section what other videos you'd like me to upload. There is an entire series on topics that are only tested on the ACT, like vectors, polar coordinates, advanced trig. I've linked to it in the description box, so be sure to check it out. I'll see you guys in a new video. Take care. Bye-bye.